Do you mind if I show everybody the one that I gave you?
Yeah, that's fine.
Let's see. So with mom, one of the things I discovered was um, this is Rhiannon's problem from 8.1, 8.2. And so I don't know if you can see the green arrows and the yellow box. The yellow box is Rhiannon's answer, and it's technically a correct answer. So I actually gave her a point back, but mom didn't like it because mom wants you to go ahead and split it into two fractions.
Mhm.
So the red arrow is pointing to the second red arrow is pointing to the way mom prefers to see the answer. Now the first red arrow, Rhiannon wrote a correct answer, but it wasn't complete because it can be simplified.
Mhm.
If you split it into two fractions, you get 12 over 3, and that reduces to 4. And then the other one, you get 9 over 3, which reduces to 3/8. So the final answer does have a much more simplified form. And so Rhiannon needs to go a little bit further. I don't know if that's just a matter of
I did
typing it,
write.
Rhiannon, that happened in 8.3 also.
Well, I had also simplified it. Like I reduced it to a 4 plus 3i the first time and it said it was wrong. So then I just went back and made it longer form and it said it was wrong. So I was really confused. Then at one point, there was one that was like a decimal, like you could divide it and it would be like a decimal because it wouldn't divide whole. I did it that way and it still was incorrect.
Okay, so I'm loading up your problems here and I'm going to look at the ones that, so you got a bunch of green check marks here. Okay, here we go. Here's one that's not right. Let's see if we can figure out what happened. So this is 8.34 and we're looking at number 9. So
Because originally I had left that in like 10 over 11i or 10i over 11 and they said that was wrong, so then I divided it and left it in a decimal form and then it was still wrong, so I was really not sure what they were asking.
well, one little thing on this one is a math error, small math error, but you have 31 and 31 is divided by 11.
Oh yeah, okay, yeah, not 3 times. I was thinking
Yeah,
through it,
so
but it's just going too fast trying to get it
yeah,
done.
so that's probably the math error, but this one also probably needs to stay exact as a fraction. Well, no, here you got 3 decimals. It accepted 3 decimals. So it's probably just that 31 over 11 and you put 3. I think that's the only error. Um, so yeah, you'd have to leave it as 31 over 11 and 10 over 11. I wonder if I can change it.
That was the first form that I left it in. It didn't allow that, so I was like, okay, it wants me to divide it all the way.
Okay, let's type it in that way and see. How do I turn that off?
Well, it's not going to correct it because it gave you the right answer already.
Oh, and also it's past due. Yeah, I was trying to see if I could type in the corrected form. Yeah, so um, I don't know, maybe you just put a fraction upside down or something. But that's kind of the form it wanted on that one. Let's check the other ones here. Yeah, so I'm suspicious. I'm wondering, it took this decimal here, but typically you should go for the exact form whenever possible and not go decimal. On this one, 11 divided by 6. Okay. And here on
Well,
this
see, like
one,
this one, for instance, I would have left just like it said it wanted it, but because they didn't divide into it nicely, but then it didn't want to take it that way.
well, this one,
Like
there
the
was a
one to the
mistake
left
on,
divides nicely.
Rhiannon, there's a mistake on the second one. 11 divided by 6 is 1.833. That is correct. But you also have to go 5. Square root of 25 is 5 divided by 6. But you only put 5i. And it
Okay.
should be 5 over 6i. So that's the part that went wrong with this one here. And this is 4i. And that's the same mistake that happened on this one over here too. You're forgetting to divide both of them.
Okay, I see that.
Because on this one, 16, square root of 16, that is 4, but it's 4 divided by 2. So that should be a 2i right there. So on both of these, it was the second number you didn't divide by the bottom. Is that
I just
making
think I
sense?
was just I was trying to go fast, and then when it wasn't accepting the other ones, I didn't realize look it past my mistake on it.
Yeah,
As far as like I was thinking it was just like, oh my god, it's not taking the number again. It's not taking the number again.
yeah. Yeah, mom is, I think one of the things I want to encourage you with is mom is pretty reliable. So these answers are pretty accurate. And so if it's coming out wrong, the first thing you should do is question your math and say, okay, where's my math error? So that way, because if you question mom first, then you won't be learning your math errors. And mom is pretty reliable. Because it's open source, anytime there is a real mom error, it goes out to the internet world and everybody starts commenting about it, and the teachers comment about it and send it back to the author, and the author fixes it. So psychologically, if you doubt mom, then you won't learn your math mistakes. So I'm just trying to encourage you that think that first. Think about it. It's like, okay, what's my math error? Cool. Good. I like how you're studying though, Rhiannon. You're really processed. You work through them all, and you've got the basic ideas. It's just little details you're missing. So you're doing a good job, Rhiannon. As far as your knowledge is good. It's just some math operation details. How about others of you guys? Have any questions? Anything you want to ask about? Okay, so today we have 3 things that I would like to do. I want to extend this subject of complex numbers. You've used complex numbers for solving quadratic equations. And there's just a little skill builder that I want to add onto it. The complex number math that we're looking at on the screen right now is division. complex number divided by a whole number. Now, another skill that I want you to take with you to the next semester is adding complex numbers, subtracting them, and multiplying them. And so our book doesn't actually have any instruction on that. So I'm going to give you some supplemental instruction and a mom homework tonight. Excuse me. I think you'll find it's pretty easy because you already know how to do the complex numbers because you know how to do polynomials. So it'll come, I think it'll come easily. But that's one thing we want to do is complex numbers. Then we want to review for the test. And then we want to look at 9.1. So that's the game plan here. Let's do some work with complex numbers. There is no place really in your book for this. So I recommend you get out a piece of paper. And at the top of this piece of paper, I want you to take some notes and title it Chapter 8, Chapter 8.4 Skill Builder. And then we're going to do some problems together, and then I'm going to have you guys do some. Okay, let's get this guy going here. There's a lot of blank real estate there. Oh, that took care of that problem. All right. So, Chapter 8. All right, so first, we've already learned that the square root of -1, it's not a real number. And so, but it does work as a number. And so mathematicians and everybody for a long time didn't know what to make of it. Finally, somebody decided, well, you know, even though we don't understand it, it works like a number. And so eventually it got called the imaginary number. Okay, now, what is I to the second power?
One.
Say again?
1.
Close. So in real numbers, -1 to the second power is -1 times -1. And that does equal +1. So, but that's just the normal -1. This is not the normal -1. This is the square root of -1. So I squared is going to equal the square root of -1 to the second power. Now what happens when you put a second power on a square root?
It gets rid of the square root, right?
Exactly. These two operations cancel each other out. So we're going to get -1. The second power and the square root cancel. So what's left is what we started with. What is I to the third power?
Positive.
Well, you're on a track here that's good. What did you say, Rhiannon? Positive what?
+1, just 1.
You're on a good track. It does come around, but we're not quite there yet. I cubed is kind of like, not kind of, exactly like I squared times I, right? Because if I put this as a first power and a second power adds up to a third power. And just a minute ago, we figured out what is I squared. I squared equals -1.
-1.
Yeah. So this is going to equal -1 times I. Well, a -1 times I equals -I. Okay, so I equals I squared equals -1, I cubed equals -I. Let's do I to the fourth power. So, any guesses? What do you think I to the fourth power is? Ronan, you kept trying, and you were on the right cycle.
Positive I.
It turns out it is positive. Let's see if we can figure out exactly what it is. Now, I to the fourth power, it's kind of like I squared times I squared. But wait, what is I squared?
Just 1 times 1, 1.
Yes, exactly. I squared is -1. The other I squared is another -1. A -1 times a -1 equals 1. Look at these answers here. The answer is I, -1, -I, +1. They're not getting bigger. When we normally multiply powers, you know, first power, second power, third power, fourth power, in real numbers, it gets bigger and bigger and bigger and bigger. Now let's do I to the fifth power. Let's try to figure out what that is. Well, I to the fifth power, it's kind of like, it's not kind of, it's exactly like I to the fourth power times I. But wait, what is I to the fourth power?
So it's +1 plus a -1?
Okay, so let's see, there is a +1. You're right about that. That's good. But there's no plussing here. It's all multiplying. Because I have I to the fourth power times I to the 1 power makes I to the 5th power, and I'm trying to understand what the answer to I to the 5th power is. So, but I figured out I to the 4th power equals 1. So this problem is like 1 times I, and 1 times I equals I. I to the 5th power equals I. These powers of I have a very interesting pattern happening here. Let's do I to the 6th power. Well, let's see. I don't know what I to the 6th power is, but if I break it up, I know the ones before, so I can break it up into I to the 4th power times I squared. And we've just figured out from before, I to the 4th power is 1. So this equals, oops, I to the 4th power is 1. But wait, what is I to the 2nd power?
-1.
That is -1.
Can it equal -1 then?
Very good. It does equal -1 in the end. I to the 7th power. Now let's see. Can somebody guess the answer without doing the algebra?
-I.
Very good. It is -I. Because I to the 7th power, it is like I to the 4th power times I cubed. Now we've already figured out that I to the 4th power is up here. It equals 1. So this is 1. 1 times I cubed. And I cubed, we've already figured out, is up here. It's -I. And then I to the 8th power. What is I to the 8th power going to equal? Well, I to the 8th is like I to the 4th times I to the 4th. And up here, it's an important answer. I to the 4th equals 1. So this is 1 times 1. This is 1. You see the pattern? I, -1, -I, +1. I, -1, -I, +1. These answers are going in a circle. They're coming back on each other. Now, there's two ways to do these problems. One is to think about it in terms of 4th power. Another one is to think about it in terms of 2nd power. Which way is best? Let's see, 4, 2. Let's try it both ways here. So now we've got this pattern here, but what if we want to simplify I to the 27th power? Now, to do this problem, we do not want to do this 27 times to figure out the answer. So how can we get around this? Well, there's another exponent law. Do you remember the exponent law? If you have a base with a power and another power, you multiply the powers. Well, if you take this multiply of powers, you can do this in reverse. If you factor the powers. Now I'm looking at 27 and thinking, okay, how am I going to break this down? Well, what I'm going to do is break it down into I to the second power. How many second power i's will go into 27? A little bit of calculator work. 2 goes into 27 once. That's 2. Actually, let me just put 6 is 13. 2 times 13 is 26 with 1 left over. So I have a remainder. A remainder of 1. So I can take 13 powers of I squared. So what I'm doing here is trying to rewrite 27th power because I don't want to do 27 of these multiplications. That's going to take forever. So I'm going to try to change I to the 27th into second powers of I. So I'm going to say I squared. Now, how many powers of I squared go into 27?
13?
Exactly. If I do 13 powers of I squared, how many i's have I taken care of so far? Well, 13 times 2 is how much? It's 26. So if I break down I to the 27th into I squared to the 13th power, this equals 26 factors of I. But I don't have enough. I need 27. So I have 1 left over, 1 remainder of I. You guys with me?
Yes.
So by breaking the 27th into powers of I squared, this is going to simplify because what does I squared equal?
-1.
-1. That's easy. Now I want to do -1 to the 13th power. So negative times a negative times a negative times a negative times a negative. I'm going to do 13 multiplications. Now you don't need a calculator because it's a negative power. What is the answer going to have to be?
Negative.
-1, because an odd power on a negative number is going to have a negative answer. And that's going to equal -I. So it's falling in this cycle here. These first 4 answers repeat. I, -1, negative I, and +1. So we're just going to get a repeat of one of those 4. And if you break this down into I squareds, eventually you can shortcut and get the answer without having to do 27 powers. Let's see. Here's another example. I to the 65 power. I want you guys to try it. Now, of course, you get it here, right? You don't want to do this I to the 8th, I to the 9th, I to the 10th, I to the 11th, 65 times. That's going to take forever. So we want to break this up and rewrite it. So give it a try. Kind of use this example as a clue. It all has to do with I squared. That's what we like. So Daniel and Christy, would you give me a thumbs up when you've got it? The other people I can see if they're done by their faces, but if you give me a thumbs up, then I know you're done. Okay, good. Yes, I see that, Christy.
Mr. Eckert, what would you use for half?
Half.
Yeah, because 35 divided by 2 is 32 and a half.
35. My writing looks a little bit
I mean,
sloppy,
65. Sorry, 65 divided
but
by
you're still, it's not so much a half, it's that you're going to have one I extra. So 65 or 35 is going to come out the same because you've got this extra remainder of 1. But how many times will 2 go into 65?
32.5 times.
Yeah, so now we can't do a 32.5 exponent. But we can do a 32 exponent. So I've got, because I want to keep it simple, right? So 32.5 is not a good simple exponent, but a 32 exponent is. So if I do 32, a 32 power on a 2 power, what's my power?
A -1, right?
No, let's get the powers sorted out first. If I have a 32nd power, you're right, inside is a -1.
Yeah.
Charles, you're right. A 32nd power, though, on a second power, how much is my exponent so far?
16.
We have to multiply power on a power. So we're using this rule here. Power on a power, you times them.
64.
64. So a 32 power on a 2 power is 64. This is not equal yet. I to the 65 doesn't equal I to the 64. So I need to multiply times 1 more I to the 1 power. So this is a 64 power times 1 more I to the 1 power. So when I add 64 with 1 more exponent of I, I'm going to get it equal to 65 power. You guys see that little trick?
And you would just write that as an I, correct?
Yes, you don't need the 1 power. I'm just emphasizing that I have to take a, the exponents equal 64 plus 1. So I'm just writing that extra 1 to emphasize that. I'm taking 65 into 64 plus 1. Now, the reason I wanted it is because this is real simple. What is I squared equal to?
A -1. Yeah.
Right. So I squared was on the inside. It has a 32 power on it times an I. And now we're really close to simplifying. What's -1 to the 32 power? A negative with an even power. What is a negative with an even power going to have to be?
Negative.
Positive.
Well, what if you have a negative to a second power?
That's positive.
Right. A negative times a negative will be positive. What if you have a negative to a fourth power? Negative, 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 negative. So these two will be positive, and these two will be positive. In the end, it's going to be positive. So if you have a negative to an even power, it's always going to equal a positive answer. So this guy is positive. +1 times I is going to equal I. Okay, well, I want you to do one more of these imaginary numbers, and then we're going to switch to complex numbers. What is I squared times I cubed times I?
Are you supposed to answer?
Yeah, this is something I want you guys to simplify.
It's I6.
Okay, I to the 6th power is correct. Do you guys know how Christy got that so fast? So we have these exponent laws, a power on a power. You multiply the powers. Here's another law. A to the n times a to the n. What's the rule on this exponent law?
You add them.
Yes, Adam. That's how Christy got it so fast. Because she used that exponent law. 2 plus 3 plus 1. This one doesn't have a power, but it has an understood power of 1. And that's how she got I to the 6th. So that is correct, but it's not finished.
We know that I to the power of 6 equals -1.
Exactly. So if you don't memorize all of these, that's fine. Just do this second power trick again. I squared. How many I squareds can we get to go into I to the 6th? Well, 2 goes into 6 3 times. So let's put a negative as third power on the 2 power, because 3 times 2 makes 6. And I squared simplifies. It simplifies to -1. And then what's -1 to the 3rd power? Negative times a negative times a negative equals -1. Make sense?
Yep.
So this is complex numbers. Really, this is just the imaginary number. We're doing math on the imaginary numbers. Now I want to kind of up the level a little bit and do some complex numbers.
So, Mr. Eckert, if it's an even number, you're going to have like I, and if it's a odd number, you're going to have -1.
Not necessarily. You're going to have 4 possibilities. You're going to have one of these 4 possibilities. Sometimes it comes out as I, sometimes it comes out as -I. Sometimes it comes out as a -1, sometimes it comes out as a +1. So here,
Okay.
I had a -I, Here I had a positive I, and here I had a negative 1.
It just depends on the exponent.
Yes, it depends on the exponent. You're going to have 4 possible outcomes. An I, a negative I, a negative 1, or a positive 1. It'll be one of those 4. And it just depends on the powers. Now, if the power is even, 6 was even. If it's even, you're going to get a 1 or a negative 1. If you start out with a power that's odd, like 65 or 27, you will get an I or a negative I. So here's an odd 27, it came out negative I. Here's an odd 65, it came out positive I. So that part is just going to depend.
So just to repeat, if it's odd power, it's going to be a positive I or negative I. If it's an even power, it's going to be a positive or negative 1.
Correct. You got it. All right, so let's see, chapter 8, skill builder. Still on complex numbers. And this time we're going to go to the next level. We're going to go to the formal complex numbers, a plus bi. And we call this part here the real part. Or the real number in the term. And then we call this one here the imaginary part. Or sometimes it's called the imaginary term. Now, I want you to be able to take these kinds of numbers and add them, subtract them, multiply them, and divide them. Well, and we're not going to do too much with dividing them. We're going to add, subtract, and multiply them. So, for example, (3 plus 7i). Now, we don't need parentheses, but I'm going to put parentheses for effect here. I have a complex number plus I didn't do consistent colors, but so I have groups here, and especially with adding, the parentheses are not doing anything. I'm just putting there for emphasis now. I have a complex number plus a complex number, but because it's add, the parentheses aren't really doing anything. Subtraction, no, that's different. Anyways, take a wild guess. What is that going to equal?
So 1 plus 7i over 6i? I don't know.
You're really close. Good job. Half of it was correct. This is all adding. 3 plus 7i plus negative 2 plus 6i. It's add this plus this plus this plus this. Now, can we go 3 plus 7 and get 10?
No,
No.
Why not?
they're not like terms.
They're not like terms. Can we go 3 plus negative 2?
Yes.
Yes,
Yes.
that's the part. Rhiannon did that exactly right. Because this is a constant number, a constant number. This is the real part and the real part. The real parts are real numbers that I can add up. And I
Oh,
get
so we could
one.
add the 7i and the 6i.
You're right, exactly. This is like 7x plus 6x. They're like terms. 7i plus 6i adds up to 13i. We're done. adding and subtracting complex numbers is as simple as like terms. So you guys really already know how to do this because when we did polynomials, you already got good at this because you understand the like terms. But let's be a little bit more cautious now. 3 plus 7i minus negative 2 plus 6i. Now, are the parentheses doing anything?
Yes.
Yes.
And the
This
negative.
minus is subtracting the whole group. So if I'm subtracting the whole group, what is this subtraction going to do to that complex number?
Make it positive.
Everything is going to switch signs. Everything. So I want you to take the parentheses off and use algebra correctly to simplify this without parentheses. So write the next step without parentheses. Some of you may have finished it already. So this minus has to distribute. So I'm going to have 3 plus 7i. No change on the first two. But this minus on the negative 2 makes a positive 2 here. But that's not all. This minus on the outside of the complex number has to distribute. So what's my next sign?
Negative 6i.
Minus 6i. Notice how the subtraction distributed changed both signs. But now, no parentheses, I just collect like terms. So now it's just like adding like terms. So 3 plus 2 is 5. 7i minus 6i is plus 1i. So there is my subtraction answer. Any questions? Okay, what about multiplication? So before we start, what is I times I?
I squared.
I squared. And what does I squared equal? Yeah, Charles is trying to give me sign language. It's -1. That's
Sorry.
important. No problem. It's fine. It's kinesthetic knowledge where you're using not just words, but you're using your body. So you're learning because you're using your whole body. Now, when we get into multiplying, this is going to be important because we'll have to multiply complex numbers. So here's an example of a multiplication problem. 3 plus 7i times minus 2 plus 6i. So this is not add, it's not a subtract, it's multiply of a group times a group. All right, wait, take a wild guess. How are we going to multiply this?
And by using FOIL.
foil, exactly. You already know how to do this. A group times a group is just going to be a foil. So when I do the first, I will get -6. When I do the outside, what is 3 times 6i? Somebody else help me out. If you haven't answered one of these, give me an answer.
18i.
Right.
Yeah.
3 times 6 makes 18i. Okay. A new person. So another person that hasn't answered yet. I'm going to do this inside multiplication. 7i times -2.
-14i.
Very good. Thank you. All right. Another new person. What's 7i times 6i?
The 42i?
Plus 42. The 42 part is correct.
Needs to be squared.
It's also 6 times 7 is 42, but it's also I times I. We have to do this. I times I is I squared. Now, when you did it before, it was x's. If you did that one before, you would have gotten 42x squared. And that's how you did it with polynomials. Well, that's how we're doing it here. It's just that when we do it here, it is I times I, so we need I squared. Let me pause for a second. Any questions on those 4 multiply answers?
I do. Would we rewrite that also as in, make it 42a squared plus, what is that going to be, 4i minus 6?
Yes, okay. So Rhiannon is going on to the next step. And what she said was correct. You could put it in order. But Rhiannon, I'm going to save us a step here. Maybe I should have done this foil all the way out. When we do this foil out here, we're going to get -6. Then we're going to get plus 18x. Then we're going to get minus 14x. And then lastly, we're going to get plus 42x squared. Now, -6 has no like terms, but the x's do. That gives me plus 4x. And the 42x squared is stuck and has no like terms. And x is a variable. X is an unknown number. Since we don't know what the number is, we can't plug in the number and do the math. Now that's slightly different than this. In a moment, some of you will see that you can skip steps here, but I'm not going to. 18i minus 14i is plus 4i plus 42i squared. Now, as far as the foiling goes, it's exactly the same as foiling. But what's different is I is not an unknown. I is a number. And I squared has an answer. What is I squared's answer?
Negative.
Right. I squared turns into a real number. It's not imaginary anymore. I squared becomes the real number -1. And so when I get this problem, I am going to have the real number -1 times the real number 42. I get a negative 42. So I squared becomes a real regular number. It becomes negative 42. And the negative 42 combines with the real number 6. And so a positive 6 and a negative 42 is negative 36 plus 4i.
Why was that 6 made into a regular 6 instead of a negative?
Oh, it's because I spaced out. This says negative 6. It's supposed to stay negative. My bad.
So that would be a positive 36, right?
No.
It's negative 48.
Yeah, sorry. Yeah.
So I have a negative number, real negative 6, and a real negative 42, which is a real number, negative 48. How are you guys doing? Making sense?
Yep.
So you have 15 of these in Mom tonight. A couple multiplies, a couple subtracts, a couple adds, and a couple imaginaries with exponents. And so that'll give you some practice with complex numbers. And the test will have a couple of these. So
When is our test?
the test is, it's supposed to be today. What day is today? Is the 1st. Yeah, our test was supposed to be today, but we're a day off schedule. So the test, I'm going to make it due Monday. And we'll do something very similar where I'm going to have an online test that you can do anytime you want before class. And then I'm going to have an in-class part of the test, which is just a few problems that you'll post in class. And so we're going to review for that test next, but we're going to take a break now. It's 1:32. Let's take a break till 1:42. And then we'll come back and we'll start practicing for the test. So I'll see you in 10 minutes.